Okay, we're continuing with the projectile motion, the ballistic pendulum, and we're going to fill out the data table one. But first, let me show you a little bit about what's going on here. We have here, this is the pendulum, the brown mass here. That's the pendulum, and you can see that we can go anywhere from uh, mass of 5 kilograms down to 3 kilograms. So it has a range in here. Let's the speed of the bullet, 225 meters per second down to 100 meters per second. And the mass of the bullet can go up to 100 grams, a tenth of a kilogram, down to um, 0.05 kilograms, 50 grams. And let's just think about it. The the least interaction would be if we have a small bullet at a low velocity into a massive block of wood. So let's fire this. First, let's put this down at 0. You can see that the height, the H, is right there at the bottom of the block. And let's fire it. Oh, and it barely, it does budge, but let's see, it's going to be hard to measure. Right there, it's about uh, 0.05 meters, 5 centimeters. Um, so that's uh, not much data there. Now let's go to the other extreme. Let's go to the massive bullet at a high speed. So the mass of the bullet is 100 grams, 0.1 kilogram, 225 milliseconds of the velocity. And let's make the block as light as we can. And you can see that I'll reset and I'll fire it. It really swings it swings it up. Let's get a measurement there. No, not quite there. It looks like 2.68 meters that it swings. Well, we're gonna pick something intermediate. I'm not gonna know what it is. I'm gonna hide it, but we're gonna put the mass of the bullet somewhere in the middle. We're gonna put the initial velocity, which you're going to find in this experiment, and we're gonna put the block of wood somewhere. Oh, let's just make it 4 kilograms. I'm gonna mass I'm going to put it at 75 grams, 0.075 kilograms. We don't know what the mass of the I'll put it somewhere in the middle. I don't know what it is. I really don't know what it is. I can show I can look later on and see what it is, but we're going to find that out. Let's just reset it. And luckily this thing doesn't diminish there's no damping on this oscillation of this pendulum, so we can measure without having to pause it. So those are the only parameters that you can vary here. The mass of the bullet, the initial velocity of the bullet, and the mass of the wooden block. So the mass of the wooden block, mass of the pendulum, bobbin support. This is data table 1. Mass of the wood block is 4 kilograms, 4.0 kilograms. The mass of the ball is 0.075 kilograms. And the height H1 in that they're expecting in the data table 1 is 0 meters in this case. And let's fire the bullet, and now we can see how high this goes. That's too high. That's a little too low. That. That's close. Can I get it at 44? No, I can't. Well, 45 looks good. So I'm going to say H2 in this case is 0.075 0.45 meters. And that's all the data that we need. Uh, the height is 0.45 meters. The um, we started at 0, and we've got so in the H equals H2 minus H1. That's an error. It says H equals H2 minus H3. It should be H2 minus H1. That's going to be 0.45 meters since we started at 0. And there's no angle. There was another pendulum bob that all they give you is the angle, and that's when you would do the L minus L cosine theta. For those of you that don't have the uh, the experiment in front of you, this probably doesn't mean much, but to those of you that are, it does. Okay, so I'm going to stop the share and reveal what the actual velocity is, and so I can compare it with what you calculate. So I'm going to stop the share, look at the okay, and I'm going to record that. Okay, so that should take care of the this portion of the experiment. Now it has a bunch of trials. If we were to try it again, I'm sure we would get the same. Let's reset. Let's not change any of the parameters, and let's fire. And yeah, it's the same. So there's no real reason for doing the several trials. If we were doing a physical experiment, there would be some variability, and we would want to try different trials and get the average. But in this case, we're just going to uh, use the one experiment to calculate the velocity. Okay, let's end this here.